Okay, lemma is a kind of theorem. Oh, someone is writing. Okay, a logic. Aha. Yeah, it's a kind of logic. Yes, I mean it's a theorem. So theorem is a logical result derived from the definitions. Okay, and lemma is a kind of theorem, but it's usually a very small theorem, not very complicated for most cases. But lemma is actually used for proving some other theorems. Okay, so lemmas are theorems that are used for proving other theorems. So this means lemmas are useful. Okay. Okay. Let A B X be set such that A is a subset of B. Okay. Then the following hold. A intersect B, A intersection X is a subset of B intersection X. And A union X is a subset of X union X. Okay. By the way, this expression means this: A intersect X is a subset of B intersect X. Okay. This sounds trivial, but don't get confused. This does not mean A intersect X subset, let's see, B intersect X. It doesn't mean, this is nonsense, right? Because this is not a subset. Okay? This is not a subset. This is a logical expression. X is a subset of B. It's just a logical value, right? True or false. But this is a subset. This is a subset. You cannot take intersection between a subset and a logical expression. So this is nonsense. So this means this. Okay. And of course this means A union X subset X union X. Oh, this is not X, sorry. This should be B, right? This should be B. It's a typo. Okay. So, in this lecture, we try to prove every lemma or theorems. And you should get used to the logic here. Okay, let's prove the first one. So, suppose C is an element of this. Okay. Why do we suppose this? Because we want to prove this is a subset of this. Then go back to the definition of subset. So if A is a subset of B, that means if you pick an element of A, whatever the element, every element, then that means X is also an element of B, right? So if we want to prove this, we pick any element of this and show that that also belongs to this. That's what we want to do. Okay. So let's say, suppose C is an element of this one. Okay. Then by the definition of intersection, that means C belongs to A. And also, of course, C belongs to X. right? That's the definition of intersection. But by assumption, A is a subset of B. That means C also belongs to B, right? Because C belongs to A and A is a subset of B, that means C belongs to B. But because of this, C also belongs to X. So that means C belongs to B and C belongs to X. So that means C belongs to the intersection between B and X. Okay? So therefore, from this assumption, we derived this result. That means, and you could pick any element of this intersection. So that means for all elements of A intersect B, C belongs to B intersect X. So that proves this proposition. Okay. Oh, this is a typo. Oh, there are too many typos. So that's okay. Similarly, if we want to prove this, we pick any element of this and show that it also belongs to this. Okay. So suppose C belongs to A X, A union X. Then by the definition of union, C belongs to either A or X, or maybe both. It doesn't matter. So let's say this is true. Then because of this, C belongs to X. Right? So if this is the case, then C of course belongs to B union X, because this means C belongs to B or X. But because of this assumption, we have C belongs to B, so C belongs to B union X. That's true. But on the other hand, if we assume this one, we are assuming this is if this is true, right? But if this is not true, then this must be true. So if we assume C belongs to X, then that means C belongs to B union X. Right? Because C belongs to X, so C must belongs to this. So therefore, any element C of A union X belongs to B union X. Therefore, this is a subset of this. Okay. Any questions? This is a very typical technique for proving some set theoretic propositions. Okay. So try to reproduce this proof on your own. Okay. Okay, next definition. Complement. Let A be a subset of the universal set U. The subset of U consisting of all elements of U not in A, okay, is called the complement of A. Okay, so this is like this. So let's say this is the universal set, and we have a subset A. So the subset of U consisting of all elements of U not in A. Not in A. So all elements of U not in A is these elements. Okay? So outside of A. And that is called the complement. And complement is written like this, or this, or this. Okay? So this is like U excluding A, or A prime, or A C. Okay? So A complement this, or U minus A. Okay? In this lecture, we mostly use this notation for complements. Okay? To be more formal, this complement is defined by this property. This is a property here. In this case, the property is this: x does not belong to A. Okay? And you should notice these equalities. Okay? The universe consists of A and non-A's, and complement of A. Okay? If you look at this, this is actually a Venn diagram. So this means the entire U consists of this part and this part, right? If you pick any subset, the entire universe can be split into two parts: this subset or outside of this subset. And also, if you take the intersection between this and this, it's empty. It's trivial, right? So if you take the intersection between this part, inside this part, and outside this part, there's no overlap. So